All right, hi everyone. This is going to be just a video demonstrating my workflow of how I go about designing a foam board RC plane in Fusion 360. I know there's a few videos about like how to do metal bending and sheet metal stuff in Fusion, but not a whole lot specifically for RC planes. And I find it a very useful tool, so thought I'd just kind of go about my process. I'm going to be designing a plane similar to this. I just need to make a few modifications, and I thought since I already have most of the design, this is a very good way I can like quickly explain how you go about designing a plane like this. I'm going to move a little fast, but hopefully you're coming in with some Fusion experience. If not, the good thing about videos, you can stop and start as you wish. So hopefully you can follow along. Plane. I think I'm going to start with the wing. This wing is going to be basically identical to the last one. Only issue, I discovered that I put a spar in the middle. I thought the spar was 12 millimeters tall. It's actually only 10. So the wing came out a little weird. But other than that, all the dimensions and stuff are going to be the same. And I think it was 200 millimeters long by 1,000 wide. Yeah, looks about right. Cool. So with the wing is actually kind of unique in how you do it for a sheet metal. You'll kind of see along the way as I'm designing this. But what I like to start doing is just design a rough sheet, like a rough shape of the outside of the wing, and then I can go back and add thickness to it, and then that's where I add all the stuff necessary to make it unfoldable like a sheet metal part. I guess maybe is now the time I started dimensioning this. I'm using 5 millimeter thick foam board, so all the curves I try to make at least 6 millimeters, just to give a little bend. And really, with the sheet metal tool, there's all these like rules about how the bending works on them. Um, really, I found foam to be a very forgiving material. Starting to look better. So I think what kind of helps is when I do the offset, and this will help illustrate what the goal of the wing is. Like I said, 5 millimeters. Actually, I'm going to be precise with this. I'm going to make a parameter of foam thickness, just in case that changes later on, and so I don't have to keep typing 5 like a million times. So thickness of foam thickness. This end, I'm going to have to change a little bit. What I actually want is for it to look something like this. And I'm realizing I really shouldn't have made this 200 millimeters. I'm going to say like 160. That way the wing can extend down the bottom to get the full 200. All this, it sounds a little nebulous right now, but it'll be more obvious as I go along. This is looking pretty good. Once I close up these edges, I'll have a solid body to work with. Cool. So like you saw, there's really no precise science to this. Just kind of playing around with what looks right. I'm sure if you had optimize it, there's um, ways you could make the swing more efficient. But for my use, this looks about right. Although this looks a little long, so I'm going to change that. This is very important, and you'll see why soon. You can't have a completely joined body. If we want it unfolded, we need to make sure there's a gap. But I'll explain more of that later. Um, that is looking pretty good. I think actually this whole thing, we can now say it's 200, and this is kind of the beauty of doing it this way. Well, it would be if these constraints would hold up. Okay, that all looks good. Cool. I'm satisfied with that. Um, and then, like I said, the wing length is 1,000. I like to keep everything centered so that the origin is in the middle. That's looking pretty good. And now here's the first time I'm going to try the sheet metal tool for bending. So really, I treat this just as if it were a metal part. If you haven't used this before, it's fairly intuitive, although it's very finicky. So I just go to sheet metal. I can say convert to sheet metal. You can just select anything. And then I created this foam board rule. I just kind of put in random values, and it seemed like it had a pretty good job of matching how foam actually bends. But honestly, if you just kept it with like aluminum or steel or whatever, I think you'd be fine. Cool. So I just made that a sheet metal part. You can now see the component has the little sheet metal icon. I can say unfold, and if you did everything correctly, when you select a face, the rest of them will turn green. And when you say unfold all bends, it unfolds flat, just like how we want it. The reason I said this would become obvious why I added the little 1 millimeter offset later, had I not done that, had this been just one solid piece like this, there's no way for it to know like where to unfold. So when I then try to go to unfold and select it, it says it can't find any bends. And sure enough, none of these are highlighted, and it doesn't let me unfold it. So very important whenever you design this, make sure that it's very clear that there's no connection between the parts that are unfolding. But so cool, this looks good. I'm sure someone on YouTube is going to point out a better way to do this. I've always done a little hand wavy, how I make the curves along the sides. But it's worked okay so far, so I'm going to keep doing it that way. I think really this is the gross part, adding an undimensioned part to the outside to constrain that. Actually, if I want to, let's be precise. This is going on YouTube. I will dimension this to be the height of that. Cool. And then I can cut all this away. I guess I never defined this. Cool. And then this may look a little weird to have this like bend. That's helpful for the sheet metal. So it just has like a very defined point where it's actually bending along. And then it's too many times I do an action and then it doesn't let me unfold anymore. So after like every action, I just make sure it unfolds. I always hit cancel instead of OK and then refold, because for whatever reason, whenever you unfold, it adds something to the timeline. And I really just like my timeline being filled with times I'm checking if it folds and unfolds. But that's looking good. I think I'm going to go one step at a time and mirror as I go. So I'm just going to emulate this on the other side. Next step, I'm going to add ailerons. And really all the values I'm getting for this have just been past planes that I've built, trial and error. But really a lot of these things, like you don't need precise science to figure them out. It's just kind of like what looks right. Actually, aileron size is something I've tried a lot, and this seemed to work well, which was 50. And then I guess really the constraint I want is I need to leave some space for the fuselage, which I'll say is 80 on each side. And if you're wondering why I have a 2 millimeter gap, that's just space for when it's laser cut, to make sure that the aileron has like a little bit of movement. If I just had this be a single line that it cut, there might be some resistance as the aileron moves up and down. Cool, and then you'll notice that the aileron goes a little past the bottom. In the past, I just left it like that, but then it very much restricts the range of motion of the aileron because it can't go all the way down. So my solution to that recently has been just to find this, and then I find you can't just cut it off at the length of the aileron. You actually want to add a little extra. And really you can be pretty, you can leave a lot of extra space. It doesn't seem to affect aerodynamics a ton. I'll just give it 10 millimeters. And then while I'm at it, it's been helpful to just embed the servo straight into the bottom of the wing, like so. I don't know the different servo there, but I just added this gap. This one actually turned out to be a little small. I think I'm going to say 485 by 30. just gonna center this on the wing. Cool, and then with that, I can just cut this away, just going through the bottom layer like so. And that looks pretty good. It gives plenty of space for the aileron to move and lets me add a servo in there. Once again, gonna check, make sure this didn't ruin the sheet metal part as I did it. But it looks like we're good. And you can now see, like, as we add geometries, how this is affected when we fold and unfold the wing. And all this, once again, can be mirrored to the other side. And that's the wing. Next up, I'm going to make the fuselage. It's actually been a hot sec since I've made a fuselage with a bending side piece. You notice this one of the things I'm changing with it. This was 2 independent sheets of foam that I'd cut and then attach. But it wasn't great because then you have this split in the middle. So what I'm going to try to do is have this just be one piece that's bent slightly. But let's see if I can do this. And actually, how I begin doing all these is I just make it fully 3D, kind of map out the size that I want, and then I can cut it down into the actual foam board size. The entire length of this plane is about 700 millimeters long, but I'll worry about dimensions later. For now, just giving me a rough idea of the size. This is probably way too tall. I think this one is even a little tall, especially with how I'm designing the new one. I can trim down the length. So I'm gonna say height will be 90. And that's really gonna mess up some of my values. And actually the length of this I can say is like 60. That looks better. I think just for nice symmetry, I'll make these two taper at the same point. Ooh, and actually what I can even do, let's make it so that they both taper the same amount going in as well. Motor casing was on this one 56. That was a little big though, so I think I'm gonna say 45 for this new one. And that's looking pretty good. I think now I can do the final dimension, which is the length. Well, not the final, but one of the big ones. And like I said, 700 I found to be a good size. And now here is kind of the really crucial thing, and really this is something I should be paying more attention to, of like how I design center of mass. But what I've observed in the past is my intuition is generally that it's farther forward than I place it to be. But really what I found is by just moving where you mount the battery and where you mount the wing, it gives you a lot of variation. So I'm just going to give myself a lot of flexibility in the length I gave it here. And I think something like this looks pretty good. So I'm going to say these two are going to be touching, so it's right up against the wing, and then this distance, we'll call it 70. I think that looks pretty good. This is going to have a fairly small motor, and then we'll have plenty of room to play with where the battery goes in this. But cool, so with that, I can now extrude it. And this is where I was going to say I'm not going to add it as a sheet metal part at first. I'm just going to make this how I would if it were just like a standard fuselage. That looks good. And now what I can actually do to this part is cut the top to give it a taper along this side as well. So along the back, it's going to be 2 sheets of foam thick plus the sheet of foam for the stabilizer. So I can say this is 3 times foam thickness. Make that centered with this. And that looks good. I guess final step to actually make this a sheet metal part is I'm gonna actually go back into the same plane. Um, Actually, first off, I'm gonna add a fillet here. This is gonna be because this part's bent, and so like I said with the wing, adding a 6 millimeter radius fillet is enough that the foam can bend and unbend without it having like a sharp tip at the end. If you don't understand that though, just play along and hopefully you'll see why this is useful eventually. And I'm actually just going to define the edges that I need here. Oh, and very key, since we added that little fillet, make sure we grab those. Cool, and then this, once again, I can say it's offset by foam thickness. And then I will, oh, and I need to add end caps to this so that it's defined as a full, like closed sketch. Cool, and then we can use the intersect tool, just basically saying everything that is along this plane it's going to grab. And then you'll see it should have added, yes, just a tiny little curve. Hopefully that's enough that the sheet metal tool can recognize this and flatten it out. And for that, same deal as before, we say convert to sheet metal, select it, and then if it all worked right, we can say unfold. It hopefully, yes, highlighted that. Unfold, and there we go. Now it's kind of hard to see, but very slightly unfolding. Yeah, that kind of showed it. But that's perfect, just what I wanted. So I can mirror this whole body, and actually, I guess really I shouldn't have called this fuselage. I should call this side fuselage. I'm gonna take the back perspective and say this is the left side. We'll mirror this component along the center plane. And that looks perfect. Actually, sorry, I don't want to mirror it yet. There's still a bunch of things I'm gonna add. I'm considering that. No, let's mirror it now. We can mirror everything we add to this because it won't be much. Um, and then we can do the exact same thing on the bottom and the top, make this one piece that we then fold. So we can say new component. This will be fuselage bottom. And it's kind of a difficult part to define because there's no plane that has it in all dimensions, but I think I'm going to start at the side. And then I'm just going to project the outside edges of each of these parts, like so. And I'm not super confident that this is going to give me, yeah, you notice it gives me 2 lines because of the fold. And actually, this is a good point. I can just add an arc and this will be my bend. I'll just make a tangent to this and we can see if that works. If it doesn't, we can change it later. Actually, no, change the plan, sorry. I am not going to add the curve now. I'm going to make this a straight piece. Like so. And then I can offset all of this, including the little piece, as foam thickness. I'm just going to hide everything else so it's easy to follow along with this. Close the edges. Cool, and then this is where it gets a little funky because, like I said, there's no good plane to actually extrude this along since it has to taper at the end. But all I'm going to do is just say it's going to go the full distance from here to this plane. And then we'll just have to cut out a little extra on the back, but that's fine. I'm not super confident that this is going to unfold because of how we did those bends. So let's fix that now. Actually, just out of curiosity, let's see. I'm going to suspect this isn't going to work, and this will be a good teaching moment for if you try to do this and you find the same. Sure enough, it doesn't see any bends. I didn't add any bends to these. And really, there's not a great way to do this, but the simplest way, go back to the sketch and add the radius there. And really, I'm going to make this a much larger radius than we need to, just to make this easier to model. It's really inconsequential when we make it into a foam part because of how soft the foam is and how easy it is for it to bend. I'm just going to set these two equal to each other. And then this is going to be some very small parts. There must be a better way to do this, but for now, this is what I can come up with. We're going to include this little bend, and we're not going to include the sharp corner. On this side, it's pretty easy, but on the other side, it might be more challenging. Oops. Yeah, here we go. You can see just that tiny little bend. And then on this side, this small little sharp edge. Cool. With any luck, that's enough that when I unfold it this time, I guess I undid making it into sheet metal part. So sheet metal, try to unfold it. And there we go. Perfect. Oh, and I'm not going to hit OK because I don't want that ending up in my timeline. But that looks good. Now we can do the same to the top. And I'm trying to think if I want to make this whole thing one piece or if I want to make it a few pieces, just for ease of access of electronics. But I think let's make it all one piece. That'll be kind of fun. And then we can have a cool like bending little joint at the back, which we can bend open. But really, this will be largely the same from how we did it at the top. New component, fuselage top, and you can actually just declare it as a sheet metal part at the start. You can see it decided since I made all these sheet metal, this one's going to be as well. Cool. So now, like I was doing, I'm going to make all these into lines. And then we've got this finicky bit here again. And actually, we don't even need to make a line there. This will be a lot simpler if I just constrain it to these two and then dimension it to be like 10 millimeters. And these are actually simple enough. I don't even need to do that. I'm just going to make arcs. Cool. And I can trim those, but actually, let's just then instead, I'm not going to use that geometry. I'm going to redefine it so then I can create just like one solid sketch of everything that I need. Cool, that looks pretty good. I should actually give this a dimension, and for this one I'm going to say 6. But for this one I'm actually going to say 1 because you notice this is bending the opposite direction, so this will be the inside bend of it. Actually, I don't need to say 1. Let's say like 3. I want to make sure it's still like somewhat easy to see, just for modeling purposes. And now you'll notice as I'm extruding this, when I'm actually going to have to cut away the rest of the circle. I mean, it didn't like that. Let's just make this into radius. Cool. And then same deal as before. When I extrude this, I'm gonna first just make it extrude the whole distance. Oh, and I guess I never did cut away that one, but we can do both those. And actually, that's kind of efficient. We can do them both at the same time. Make it very fast. Cool, but now if I say unfold, it's not connected any bends. That is unfortunate. It's interesting, I wouldn't expect this one to not have picked up to be a sheet metal bend. Oh, never mind, it is. Cool, okay, so it's just this one that got messed up. Was that just in my... Oh, sure enough, yeah, I just never selected this to be extruded. So that was actually a simple fix. It should be now if I select this, perfect. They all fold flat, just how I want it. All right, so this is looking pretty good. Like I said, I forgot originally to cut away all this excess stuff, so I can do that now. And perhaps the easiest way to do this actually is to go into the side fuselage, and where I made that sketch originally, where I was cutting away, I can, there we go, this one. I can use this, cut through everything. It's actually, there we go. And then I guess I just have to make sure it's only going to cut the two pieces I want, which looks like it actually is. So that worked perfect. That just saved a sketch, made things a little simpler. Although now that I'm looking at it, that did not work because it didn't take the thickness into account. So never mind. Let's not do that. Let's instead just do it the old-fashioned way. This is kind of a tough one because I guess maybe easiest thing, I'll just do it in one of these sketches. Define a plane on the top. I'm gonna select this geometry and then select the two sections that I'm cutting away. And then it should be a simple, oh, and then I have to define this as being closed. It should be as simple as now just being able to cut through everything. And I just need to make sure that it's not going to cut the side panels. So I can deselect side fuselage. And that's looking better. You can see now it's all inside. And then it's not great because the sketch is now only in this one body when we cut both them, but I think that's fine. It saves us some time. And then I am going to double check once again, make sure this didn't ruin the unfolding, which it looks like it didn't. So that's all good. All right, so then the final thing we're going to do is create the horizontal and vertical stabilizers. So I'm going to make a new component for this. I'm just going to say this is a standard component because you're not doing any of the sheet metal bending. Really, it doesn't make much difference though. I'll do horizontal stabilizer first. And then for the plane of this, I think I'm just going to offset it by like 25 millimeters. I want it a little high on the top so we can put the servos below, but something like that looks good. Cool, so I'll just start a sketch there. The geometries we need will just be the outside edges of the fuselage. And then I'm just going to sketch a very rough shape, and then we can dimension it after. And then the way we're going to attach the fuselage is I'm going to actually make a cut in the, attach the stabilizer. I'm going to make a cut in the fuselage. I'll do it like here. And it's trying to snap it so that's perpendicular to this line. I want it to be horizontal. And then I'll connect this up. The reason I'm making a plane here is because this is going to be symmetric and it's going to be a lot easier to just make one side and then mirror it for the other. And once again, there's no like precise science to how you do this. Two things I've found over the years though, You want to have a fair amount of space here because this is where the whole horizontal stabilizer is going to actuate. And if you had this be very narrow, um, having a hard landing or even just the force of air blowing over it as it's deflected could cause it to bend and or just like totally break off. Um, so I think I'm going to try to do at least 25 millimeters on that. And then I have this cut out here because the vertical stabilizer will have a section that's actuating along this area. Um, and what I like to do for that is I'm going to define a sketch here. Um, Trying to think of a good like deflection angle. I think if I did like 30 degrees on each side, I'm actually going to say 45. No, that's too far. Let's say 30 degrees on each side. Then basically I want to have this area where there's not any stabilizer that'll get in the way. Something like that. So then easy enough, I can just make this all parallel. And really this isn't perfect because the stabilizer isn't going to be hinged right in the center. It's going to be hinged on one side of the paper, but it's easy enough. And really this is like a lot of deflection. We probably won't have it extend that far. But something like that looks good. For aspect ratio, this whole thing might be a little large. I can probably scale this down a little bit. Don't need quite so much, quite so much movement there. Cool, so then from here I can just mirror all of these elements to the other side. I'm not mirroring the center plane though. I'm going to use, sorry, the center line. I'm going to use that as my mirror line. And yeah, I think that looks good. If it wasn't already obvious why we mirror it, the cool thing is if I ever wanted to make an adjustment, you notice it's going to do both sides evenly. And so that just helps to be able to edit and come back to it. Last thing I'm going to do is the same thing we did for the ailerons, make cutouts so that the stabilizer can actuate. I don't know if this actually makes much of a difference, but I've always found it aesthetically pleasing to actually have the front of it move as well. So I'll define it, actually I'm going to define it by somewhere over here, and I'll put a precise measurement because this is a more critical feature, which is that basically it's going to actuate along this hinge, and we want to make sure that this has a little bit of space in between so that it's not just going to hit the fuselage as it tries to move. And I think, yeah, 5 is a good number for that. And actually looking again, this doesn't leave a ton of space for the whole stabilizer move, so I'm going to make this 60, just give us some extra space. This, once again, I'm going to say 2, just like we did for the ailerons. And then probably should have modeled this before we mirrored everything, but I can just go through and same as before, mirror. And I think that looks pretty good. So if you were to make the incision, it would cut like that, and then you have all of this back section that would be moving. Yeah, I like that. So then we can just extrude this. I'm gonna extrude it down just because you're a little constrained up top. And that looks good. And then same thing, but for the vertical stabilizer. This one is a little easier to define. It's just going to be the center plane. And then for important geometry, it's the fuselage. Plus we need to know where we can have the rudder actually actuate. And just for consistency, I'm going to actually get this point as well. And then this will be where the tip of the fuselage begins, or sorry, the rudder. Cool, and then just like how we added space for the rudder to actuate, we're going to have to do the same thing for the horizontal stabilizer. So this is like a cutaway area where this is basically going to be inserted after we put the stabilizer in. And we'll need, sorry, we won't actually need this. What we'll need is a line projected from this line and then up and down the maximum extent of the stabilizer. So I'm going to say 485 for this one, 485 up and 485 down. And actually, to be precise with this, I'm just going to include the whole geometry of the top and bottom. There we go, got a snapping point now, 485. And then I'll just add an arc, which will have its center point along this line, just by the geometry of how this will actuate. It's going to give a little extra space because of inconsistency and how this isn't actually pivoting straight along the center. You really can't go wrong with just adding more space than necessary. But cool, that all looks good. Once again, gonna need a relief cut at the top, which I'm gonna define like so. Once again, gonna be 2 millimeters. And then for the line that's actually gonna cut along, ideally, you have a little bit of space after here, so you'd have a line which would look like this for the rudder. But this obviously isn't giving us a ton of rudder space. So I guess there's a few ways to fix that. First, I'm just going to define this, make sure a sketch is neat. And then maybe the easiest thing, I'll just pull this whole sketch back a bit. Something like that perhaps. And then I'll actually define a distance between, oh, I guess that's not actually going to work. Let's just, this isn't super precise, but I'm going to define just like this distance. And I think we can probably increase that area and maybe decrease this a little bit. Oh, whoa. And so actually, change of plans. I'm not gonna try to make this line be outside of here. This was, I thought I could do something that would improve things a bit, but it turned out to be more finicky than I thought. So let's actually just make these two equal to each other. So it's going to have a hinge that's going to be cut in the middle, but that's fine as long as we can mount this to the fuselage. We should be fine. And yes, and then I think this whole thing doesn't need to be as long as it is now, like 30. That looks more reasonable. Cool. So then, once again, gonna extrude this. It'll be in a few different parts. Really should have made that a construction line, but oh well. And that looks pretty good. Oh, it looks like something didn't get included. There we go. That and that. Cool. And I guess two things we should still do. First of all, you'll notice if I look at interference between these, there is going to be this section where the horizontal stabilizer is cutting into the vertical stabilizer that's right now intersecting. And so the solution to that is the easiest one. Just say combine. I'm going to cut these, keep the tool. That did it to one side. I can do the same to the other. Combine this and this. Cool. And now it should be, if we just isolate one of these, we have a cutout for the stabilizer. And so that will give us a solid attachment point for the horizontal stabilizer. Vertical stabilizer is going to be a bit more challenging. Perhaps the best way to go about this, actually, giving it a second thought, is let's edit the sketch. And instead of just having it mounted on top, let's actually have it similar to the horizontal stabilizer, um, actually mount inside. So I'm gonna say this is, oops, that thickness, and I'll just give it some arbitrary length to keep it constrained, something like that. And then trying to think if there's any good way to do the bottom. Perhaps the best way would be to actually mount, I'm gonna hide the side panel so then I can get my cursor in and project this line. I'm thinking what we'll do actually is have this piece extend inside the fuselage a fair bit until we have an area that's thick enough to accommodate a cutout, and then what we can do is have this, trying to think this is the best way to do it. You know, let's keep it simple. Let's just have a little tab that'll stick inside, call it 20 millimeters. And then the goal with this is we'll just hot glue it in place, and sandwiching the two pieces of the fuselage together will hold this. So I'm going to finish, extrude these two pieces, and cool, I am satisfied with that. One more thing that would actually be really handy to have, to add, I'm going to edit the sketch again and add a tail drag onto this. We're not going to add landing gear, but just having something that'll let the tail skid might save our stabilizer, and this can be reinforced from wood. And I'm just going to add, oops, add a little fillet to the bottom, like so. Cool, I'm satisfied with that. And then final step in making this plane before we go on to exporting is making cutouts for the servos. On this plane, I forget what the dimensions are. Looks like I have a model of a servo. But it's 20-30 tall by 12 high. Sorry, 20-30 long, 12 tall. So edit this. And then probably good to move the servos a little more in, mostly because we have constraints with how thick this is and we don't want the servo punching through to the other side. All right, so final few things I'm seeing that we need. We're gonna need a way to mount the wing to the fuselage. The best way I found to do this is I just make a hole on either end and then put dowels through it and then rubber bands. So I'm gonna, I believe I have 12 millimeter tubing. So I'll put 12 millimeters on each end, constrain this together. There's really not a great constraint for the wing, but I know that it's 200 millimeters about, so I'm gonna say 100, and that'll be the center point for this. And then for the height, I think like 16 is good just to give it enough space up top. All right, and then final step, which probably could have been done earlier, but I'll just do it all now, is adding tabs so these can be assembled a little easier. You'll see what I mean in a sec. But what I'm going to do is just add on each of these, centered in the middle, a tab which is, I don't know, let's say 80 millimeters long, and the thickness of the foam. So then I'll do the same to the back. And then I'll do the same for the bottom. All right, cool. So I've got that complete. Um, However, the issue you'll notice is that if I go into interference again, you'll see that these are intersecting. So just same thing we did before. I'm going to say combine. This we can actually make pretty simple. We can select them both at the same time. Just make sure to keep the tool, do it to that side, and then do the same to this side. Awesome. And now all those are set. And with that, the plane's ready. I think the last thing would have been make a motor casing, but I actually don't have the dimension of the motor I'm using. So I'll save that for another time. If you look at the wing, it's about 1,000 millimeters long, but at least the foam board that I have, it comes in 30-inch sections, which is like 760 millimeters. So I'm actually going to have to make this wing in two pieces. And the easiest way to do that is just to split it in the CAD file, like so. Cool, and now we can get exporting. So the workflow I used for this, I'll just go one piece at a time. I first unfold the piece. Now that it's split in two, I only have half of it. That's good because I want to just save it as half. And then I have a software called Origin. They make CNC routers, but they also have this free software that lets you export as a SVG, which is very convenient because for stuff like this, I need to select multiple faces. So I'll select the four main faces. You'll notice I haven't selected these folds. That's intentional. This is stuff we can fill in our editing software. That's a lot easier. But I'll say okay. You notice I already saved one by accident, but I'll say this is wing. I'm going to replace that piece. And that looks good. Now I can go ahead and refold and then move on to the next piece, which is the fuselage side. You notice I didn't export the other side of the wing. That's because it's going to be a lot easier for us to just mirror it in our laser cutting software than it is for us to actually export both sides, because there is a little bit of post-processing that is necessary. And oh no, something happened when I made cuts. And actually, I can see what happened. It looks like this never cut all the way through, I guess. Perhaps the easiest thing, if this will work, is just delete those. And unfortunately, it still isn't letting us open it. Oh, you know what? It looks like it cut this as well when we did that intersect, and that's what's causing the issue. Okay, cool. It looks like it's fixed now. The solution was just that what happened is this didn't match the curve of this, so it was actually cutting a little bit when we did that combine command. So all I did is add a little fillet to the edges of each of these. It made almost no difference, but it was just enough such that it doesn't cut through that anymore. And now we can unfold it. So I'll unfold this, same deal, going to export this like so. You might think we could just mirror this one, but unfortunately, because those servos are in slightly different places, we have to do the same the other side. All right, so this piece seems to be giving me some weird issues where it's not letting me select all four faces on the top. And if I try to select them on the bottom, for whatever reason, it seems to duplicate the part at an angle. So I can illustrate a second way to do this if you run into a similar issue, which I'm going to start a sketch on one of these, and then I'm basically, same deal, just going to project um, all the geometry I need. And then with any luck, now when I export it, instead of saying faces, we can say sketch. And then I can select this one, sketch. Cool. And then honestly, after that, you can just delete the sketch. All right, and then the final thing we're going to do once we have all of these parts saved as SVGs is open up a graphic design editor. I prefer Affinity Designer, but if you have an Adobe subscription, you can use Illustrator, or there is Inkscape available, open source and for free. So I'm just going to say open, and just going to open all of the files I have. Cool, and then like I said, the most of this is going to vary, but hopefully you get the gist of like what you have to do to actually get this ready for laser cutting. Um, the foam board I have access to is 30 by 20 inches. So I'm going to create a blank sheet like that. I may have multiple of these. And then I'm just going to start with the wing because that's the largest one. It's going to be most difficult to fit in a sheet. And then all I'm going to do is make it have no fill. Oops, it's going to be transparent. And then the way I have my laser cutter set up, it's a black stroke to cut and a red stroke to engrave. And so stuff like this where it's going to be a score line, we don't actually want to cut that. We just want to have like a mark etched in so that we can bend it and remove foam if necessary. So to fix that, what I'm going to do is split the line. Then I can delete this one, delete these, same deal with this one. I'm going to split this, delete that line, and then this one I can just extend up like so. And then I'll do the same here. This one, we can actually just delete entirely. So, cool. And then once those are removed, we're also going to need to add the lines that are the cut lines, or sorry, the like etch lines. Technically, it's going to cut through, but it's not going to cut through the whole foam sheet. It's just going to cut part way, which will give us enough that we're able to bend it. And so I'm going to do red. Like I said, this is dependent on the laser cutter you're using. This just is how I have mine configured. And then we're going to put these lines. Awesome. So now that I have all the lines marked for this, I can just move it into my sheet and then do the exact same thing for the other ones. All right, and with that, the file should be ready for laser cutting. Obviously, the video went pretty fast. I was just kind of going as I did. You saw I made some mistakes along the way, but really that's the essence of CAD. If you have questions, feel free to leave them below. Also, check YouTube. There's so many videos explaining all this. That's where I learned how to do all of it. And hopefully this video helped you do the same. Thanks.
These two. Beautiful.